Back to my channel, and in today's video we are going to learn about linear and multiple regression analysis in STATA. And before we proceed to performing analysis, let's understand what are these linear and multiple regression before we proceed. So for linear regression and multiple regression, their uses is to examine the relationship between variables and to predict outcomes. So for linear regression analysis or what we call the simple regression, it's used when there is one independent variable, which is the x, and one dependent variable, which is the y. Linear regression or simple regression is used to predict a continuous outcome. Again, it is used to measure the effect of one variable on another one. It's also used to identify the strength and direction of linear relationship of this, the predictor and the outcome. For example, if you are carrying out a project, so you can look at the effect of fertilizer amount on maize, cassava, beans, rice yield. You can also have the effect of study hours on exam scores. You can also have the effect of age on income. So the age here become the predictor and then income is the outcome. Let's look at multiple regression. So used where there are two or more independent variables. So the difference between linear and multiple regression analysis is that the independent variable in the multiple are more than one, while in simple regression analysis or what we call the linear regression analysis, the independent variable is one. So differentiate those two and when to use. So here, these multiple more than one independent variables are predicting one continuous variable, which is the y. So you use multiple regression analysis when determining the effect of several predictors simultaneously, causing the outcome of one continuous variable. So you have to control for confounding variables when you are using multiple regression analysis. It also predicts an outcome more accurately than simple regression analysis. Also, it's identify which independent variable significantly influence the dependent variable. Because when we look at multiple regression analysis, you will realize that we have something that is called R square. So the R square is the strength of how much this independent variable is predicting the outcome. For example, we wanted to predict an household's income using education, age, work experience, and gender. The other example is we want to predict crop yield using rainfall, using fertilizer use, soil fertility, and seed variety. And then we want to predict farmers' productivity using training, farm size, credit access, and irrigation. And remember, all these factors might not be the only factors which are predicting farmers' productivity, crop yield. That's why we say that you need to control for confounding variables, which are other variables which are affecting either yield, income, or the productivity. So the data requirements for that dependent variable, which is why you must have a continuous or what we call the ratio or interval variable, e.g. income, e.g. yield, weight, or also you can measure the blood pressure of the patients. And then when it comes to independent variable, first category is the continuous variable, which is like age, rainfall, income, or we can have categorical variables after coding. because if you don't code, multiple regression analysis or linear regression analysis is not going to be performed. So we have talked about the difference between the simple linear regression. Like we say that for simple or linear regression analysis, you have one independent variable, which is predicting one dependent variable. While else, for multiple regression analysis, you are having two or more independent variables, which are predicting the outcome of dependent variable. So let's begin with the analysis. So you go to statistics, and then you come to linear models and related, then you go to linear regression. So we are going to have dependent variable as the income after. We are going to say this income after is being affected by the age. Then we submit, and then we get our results. So this is the table that we get when we perform simple linear or simple regression or linear regression analysis. So you have to read this table. So you have the important part is to read the F, which is less than 0.0, which is greater than 0.05. And then you have the R squared also. Then you have this adjusted. And then we have coefficients, standard error, and then the T, then the P value. So the P value is greater than 0.05. So let's say you had an hypothesis which was like this: age influence income after for the responding. So now you have gotten your P value which is greater than 0.5. So meaning age does not influence the income after. So you reject the null hypothesis and then you accept the alternative which states that age does not influence income after. So the important part of the table is this F value and this R squared. So in case age was influencing or predicting the outcome of the income after, we could have used this to state at how much does age influence the income after. But now it doesn't influence. We reject the null hypothesis and then we accept the alternative. Let's go back and also do the multiple regression analysis. So it will be the same, but now for multiple regression analysis, we are going to have more variables, the independent variable. So apart from age, we can look at household size. We can look at education. Yeah, those, and then we can submit. So when we submit, you find these two tables. You find the model residual table and then the other table. So when we look at the overall, the F value is greater than 0.560, is greater than 0.5, which means the age, the household size, the education encoded does not influence the income after. When you come and look at individual variables, There is none which is less than 0.05. All of them are above 0.05, which means that they don't influence income after. So thank you so much for watching this video. I hope it has helped you to clearly perform linear and multiple regression analysis in case you didn't know how to do it. The important thing is to understand their uses, the type of data that you're supposed to use. That's the first step. I usually tell people that for you to perform an analysis, the first thing that you're supposed to understand is understand your data. After understanding your data, draw a plan. Like you can have a matrix of your analysis where you have the variables and then you have the type of analysis that is fitting. And then in that type of analysis, of course, you must know this type of analysis usually require which type of data to execute. And then the other important thing is the goal. What are the objective of you doing that analysis? Your audience who are going to be consuming this data. So thank you so much for watching this video. Click subscribe, share, and watch out for more video for more learning in STATA.